At any given pressure, there is a corresponding temperature at which water will boil. This temperature is called the saturation temperature. For example, at standard atmospheric pressure, which is 14.7 psi, the saturation temperature of water is 212 degrees Fahrenheit. When pressure increases, as it does in this boiler, the saturation temperature also increases. At 1000 psi, the saturation temperature of water is 545 degrees Fahrenheit. When the saturation temperatures for water at different pressures are plotted on a temperature versus pressure chart, a line is formed showing the relationship between saturation temperature and pressure. However, this relationship between temperature and pressure only holds true up to a certain point. That point, which is called the critical point, is 705 degrees Fahrenheit and 3,206 psi. At or above the critical point, the densities of water and steam are the same. In other words, there is no distinguishable difference between water and steam. When a boiler's temperature and pressure are above the critical point, all of the heat produced in the boiler can go toward raising the temperature of the steam. But boilers that operate below the critical point always have to use some of their heat to convert water into steam. So all boilers that operate below the critical point have a built-in inefficiency. Boilers that operate below the critical point are called subcritical boilers, while boilers that operate above the critical point are called supercritical boilers.